Hello class. All right, we're going to graph our inverse functions, and we're also going to learn something a little bit about when it does have an inverse and when it doesn't. So when a function does not have an inverse, it does have an inverse, but we want to know it does not have an inverse function. Something's going to happen. And let's look at one that does not have an inverse function, and that is f of x is equal to x squared. We have x and y table for this. Let's go -2, -1, 0, 1, and 2. And we get 4, 1, 0, 1, and 4. So when we graph that, we get that quadratic that looks something like this. Now, when we go to do the inverse function, remember our x and y's are going to trade places. And so it's going to be 4, -2, 1, -1, 0, 0, 1, 1, and 4, 2. And when we graph that, it looks like this. Now, we know that this is not a function because it fails the vertical line test. But we can know that before graphing it by looking at the original function. Does this have a function an inverse that is a function? And we're going to use something called the horizontal line test. And if it fails, so we take a horizontal line, if it crosses the graph at more than one place at any given time, the inverse is not a function. So here's how the horizontal line test is worded. The function f has an inverse that is a function, which we denote with that -1. If there is no horizontal line that intersects the graph of the function f at any more than one point. So let's take a look at these. I'm just going to use a horizontal line test. There's a horizontal line, there's 1, and there's 2. So this one is no, its inverse is not a function. On this one, I can do it any number of times, and it only crosses it once. So this one is yes. This function has an inverse function. And then this final one, I can do that also several times, and it will only cross once. So this one is also yes. This function has its inverse is a function. So let's take a look at the function. Graph of function has two line segments, and we're going to have a line segment from -2, -2 to -1, 0. I'm going to write this on a table here, and then a second segment from that same point to the point 1, 2. So if I graph that, it's going to look something like this. The inverse function, I can look at this and I say, yep, the horizontal line test, it passes because it doesn't cross that at any given time. So I'm going to do an XY table for my inverse. And I switch these places. So the Y becomes the X and the X becomes the Y. And then when I graph that, it will look like this. Little note here, it is reflective over this x equals, or y equals x line, diagonal line. Okay, so let's do one with an equation here. We've got f of x is equal to x squared plus 1. And so let's give ourselves an xy table so that we can graph this. But then they also gave us a domain here. I want to just restrict that domain, so I'm going to have it greater than or equal to 0. So let's start at 0. 1, 2, 3. So 0 squared is 0 plus 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. So if I want to graph that, it's going to look something like this. So then when I go to the inverse function, and keep in mind, the inverse of that, I could find that equation by doing y equals x squared plus 1. And then I'm going to subtract 1 from each side, so I get y minus 1 is x squared. And then if I take the square root of each side, I get the square root of y minus 1 equals x. And I'm not going to use the plus or minus because that's why we have this restriction on the domain. And you know what I forgot to do is switch these places. I'm going to do it now, but really you should do it at the beginning. So it's x minus 1 is equal to y, the square root of x minus 1. But a simpler way is just, let's switch these. So it's going to be 1, 0, 2, 1, 5, 2, and 10, 3. You can always check. 10 minus 1 here is 9, and the square root of 9 is 3. And so they do give you those points. So let's take a look at what that graph looks like. And once again, please note that it is reflective over that diagonal line, y equals x. Y equals x.